Hello there, and then welcome to a brand new video. Let's have your numbers where we learn maths the easy way. Now, in this lesson and in this playlist, we'll be looking at mental mathematical strategies. For this lesson specifically, we'll be looking at how to halve and then double to aid us in multiplication. Have you ever wondered or finding an easy way of multiplying 16 by 35? If yes, then this lesson is going to teach you a very quicker method you can do this. Without much ado, let's quickly look into it. Now, before we look into it, you should understand that multiplication is associative. It is associative and also commutative. I wouldn't go much into this, but then all it simply means is the order of multiplication doesn't matter, such that if I have A times B, it is the same as what? B times A, right? Now, this property leads us to other properties, such as what we'll be applying in doubling and halving, which says that if you have an A and you multiply it by a B, it is the same as A divided by 2 times 2 times B, right? What this simply means is that if we divide this 2 by the 2, we would still be left with A times B, right? So the 2's we have there don't really matter because at the end of the day, they don't change the value of our answer. How then do we apply this property in the concept of halving and then doubling? Applying it is very simple and straightforward, as you would see in this example I'll be using to illustrate over here. So if we have a number such as 16 times 32, we want to multiply 16 by 35. What the halving and doubling is saying is that if we have one number, then let us double the other, right? So in simple terms, talking of halving and doubling, there are things we can easily do in our head, right? So if you want to halve 16, the half of 16 is actually what? 8, right? And then the double of 35, that is 35 times 2. It will give us 70, you see? So 70 over here. Now you can easily do your multiplication. 8 times 7, gives you what? A 56. Then just add your 0, right? You have your 560. As simple as that. You see how very simple it is. Well, you could have also decided to go on with your halving and doubling. So at this stage, we had our 8 times 70, right? So the half of 8, to be what? The half of 8, to be 4. Then if you double 70, that gives you a 100 and what? So the 7 times itself gives you 14. So we have 140. You can still proceed if you so do wish. So the half of 4 gives us what? 2. And then the double of 140 will give us 280. You see, then you can still proceed. So half of 2 gives us 1. And then 1 times 200 and the double of 280 will then give us our 560. You see, so you can end where you think you can easily evaluate mentally, right, in your head. But if you think you can't evaluate right away, just as I just evaluated 8 times 7, which gives me my 560, you can still proceed till you get to 1. This is a very interesting method that prevents us from doing this, let me say, complex multiplication. Let's take some few more examples. So over here too, we have another number which says we should solve 24 times 15. 24 times 15, so we'll be halving and doubling, halving and doubling, halving and doubling, that order. The half of 24 would be 12. Then the double of 15 is going to be 30. You see, at this point, you can still do your multiplication and get your answer. But if you still want to proceed, Then half of 12 gives us what? A 6. Then the double of 30 will then give us a 60. You can easily multiply 6 by 6, giving you your 36, and then you put your 0 there. But if you still insist and you want to continue, 6, the half of 6 gives us a 3, and then the double of 60 is a 120. If you know your 3 timetable, you can multiply your 3 by your 12, and then you just add it 0. Or if you still want to proceed, well, actually, we wouldn't want to proceed here, because if you proceed, then are going to look for the half of 3, which will give us a decimal. We don't want to go to the decimal domain. You see, hence we just multiply the 3 by the 12. That gives us a 36, and then we put our 0 attached to it, and hence we have 360. You see, very simple and then straightforward. All right, so let's pick some few more examples as well. So this time around, we have a word problem, right? That says a farmer planted 24 rows of maize. The farmer planted 24 rows of maize, each with 15 plants. Instead of multiplying directly, use the halving and doubling technique to find the total number of maize, right? So since we are talking of 24 rows, there are 24 rows 15 times. So that is going to be 24 rows, then times your 15 plants. To make it clear, all we want to do is to multiply 24 by 15. So using our halving and doubling, the half of 24 is what? A 12. Then the double of 15 is a 30. You can do your multiplication at this point and go your way, or you can still insist to proceed. The half of 12 gives us a 6. Then the double of 30 gives us 60. You see? So it's just like the previous one we did here. So the half of 6 as well gives us a 3. And then the double of 60 here gives us a 120. 3 times 12 then gives us a 36. Then we just add our 0 to it. Right? So it simply implies that the total number of maize were what? 360. So you can just write your answer here and say that. So you can say, therefore, the farmer planted a total of 360 maize plants. Now that brings us to the end of this lesson. As usual, I'll leave some exercises you can try on your own. So as you can see, I have just 2 sets of questions, the direct ones and then the ones involving word problems. And you are just actually going to use the same method, right? So that ends this lesson on halving and doubling. See you in our next lesson where we'll look at another technique in multiplication. Stay blessed and bye for now.